Welcome to ATEC Training's Quick Start video series. Today we're going to be working on vehicle technology trainers. We're going to be featuring the model 610N. We also sell a 610T. Our N version is a Nissan Leaf. The T version is a Prius Prime, which is a partial plug-in hybrid vehicle. The Nissan Leaf is a full electric vehicle. We're going to go over all the different parts and pieces that make up one of these vehicle technology trainers. So go ahead, get your operations manual out, and let's get started. ATEC Training believes that safety should be your #1 priority. And before we get started on going over how to work on some electric vehicle systems and components, we want to cover some basic safety information with you. Electric vehicle manufacturers may choose to limit the required use of personal protective equipment by any technician while servicing the vehicle. They do that because they may choose to rely on the integration of safety systems in the vehicle that will ensure the high voltage components are de-energized by using a scan tool or other electronic means. As the technician or the instructor, you must refer to the employer's or the OEM's specific guidelines, procedures, and training when selecting the appropriate and recommended personal protective equipment. Remember, it is your job to be trained and certified prior to servicing these vehicles. Hybrid electric vehicles and electric vehicles both contain high voltage batteries. There is the risk of electric shock, electric leakage, or similar accidents if the high voltage components and the vehicle are handled incorrectly. Be sure to follow the correct work procedures when performing inspection and maintenance. And a few additional tips that we also insist on is that you need to be sure to wear your insulative protective equipment that consists of either gloves and/or shoes, face shield, and safety glasses before beginning any work on any high voltage system. Again, refer to your repair manual for the specifics. You want to make sure also that you clearly identify the persons responsible for the high voltage work and ensure that other persons in the area are not able to touch the vehicle. And when you're not working on the car, make sure you cover up all the high voltage parts with an insulating cover sheet or similar item to prevent other persons from contacting them. Make sure to do all your safety checks first. Make sure your safety PPE is on. Make sure your vehicle is powered down. Make sure all your labels are correct and your vehicle is properly blocked off. And if you follow these simple steps, it'll help increase your safety while working on electric vehicles. Now we're going to bring ourselves and our students on out to the shop and show them exactly how the wall charging process works. We have to remember, it might seem simple, but a lot of people have never been exposed to EV cars or an EV plug. Now, this is a great time to talk to your students about the 3 different types of charging stations that are out there. They're typically referred to as level 1, level 2, and level 3. To keep it simple, level 1 is going to be a lot like this guy. It runs off of 120 volts and it takes quite a while to charge your EV vehicle up from ground zero to full charge. A level 2 is also available at home, but it's going to step it up and run off of about 220. So you're going to have an electrician most likely come in and wire that unit up for your house so you can charge your car in your garage. A level 3 charger is what we might find down at the supermarket or at a hotel or at any of the major stations that offer charging across the US. That's going to be a higher level charger. It's going to be running at about 400 plus volts that are going to be utilized for that type of unit. For today's example though, we're just going to use the trickle charge feature. We're just going to use our simple 120. It comes with the car and we're going to learn how to plug this thing in. The first step is in the driver's seat. There's a little button and it actually has a little gas can icon on it with a little lightning bolt above it to let you know that that's where you're going to press that button and it's going to open up this charge port lid here in the front. Once this charge port lid is open here in the front, you're going to reach down inside and you're going to find 2 ports in there. One port's going to have an orange color. That's for your level 1 and level 2 chargers. The other port on the left is much larger. That's going to be for your fast chargers. So once you reach inside, there's a little clip. You press the button and the door slides open to allow you to insert the charger. You're going to remove the safety plug from the front of this charger and we're going to slide this right on in until it clicks. Once it clicks, we're going to hear some active beeps. That's going to let us know that the charger is connected and the process begin. This particular model also has 3 indicator lights up in the dash, which most EV or partial EV vehicles have. I call it the feel-good monitor, but it's basically a state of charge indicator for you as far as your lights go. Now, just like in our trainer, the 5820, when this vehicle is hooked up to this charger, and we're plugged in right here, the computer already knows that we are tied in and when the charging process has started, and will not allow us to ready up this vehicle or to put it in gear and drive it away. That's a very safe feature, but definitely something that you're going to want to let your students know or your technicians know, that if there's a malfunction with the lid or with the charge port, that could potentially keep the vehicle from readying up. So one thing that we always face is that we used to call a no start. Now we're going to be faced with a lot of no ready up issues. And it's important that you explain to your students that there are a lot of integrated systems that have to work together in order to get the computer to give the thumbs up for the charging process to work. The best place to start with that is going to be utilizing your training vehicle in your lab and the repair manual information available for you. Now we're back under the hood of our 2013 Nissan Leaf. This is ATEC's vehicle technology trainer, and as you'll notice, we've labeled most of the major components under the hood here using orange labels to aid your students identifying the differences or things that might exist on an EV car that they may not traditionally be used to seeing on a vehicle they have or one that they've worked on previously. Over here on the left, we're going to see a relay box. We've got a multitude of different relays in there. Coming over here to the driver's side, we're going to see our main fuse box. And over here, we've got our MC relay box. So let's pop the cover on these and have a look on the inside. Underneath our fuse cover, we're going to find low voltage and high voltage, low current and high current fuses, things that are going to control stuff like the horn, the radio, the daytime running lights, your stop lamp, and also all the power feed circuit protection for most of your relays. If we look underneath our MC relay box right here, get the lid off of it. All right, there we go. Underneath it here, we've got our reverse lamp, our anti-theft horn, our MC relay, and our daytime running lights, our second relay for controlling those. So it's important to show your students that there are multiple areas available underneath the hood for power feed checks and relay checks. And these can be different locations what they might be used to seeing. So it's important to give them a chance to come out and look under the hood and identify where all these relay and junction blocks exist in the vehicle itself. Now let's skip over to the repair manual and have a look at some information about the high voltage junction block. I have a repair manual schematic pulled up here, giving us a shadowed image of the vehicle and the battery pack. As I mentioned before, all the high voltage battery cells and a lot of the battery management components do exist inside the pack that's underneath the car. So therefore, we're going to use some of these drawings to help us identify where certain pieces are. So labeled as number 1 is going to be our entire lithium ion battery pack. Number 2 is going to be our service grip plug. That way we can disconnect the vehicle from the high voltage battery system. Our main focus though for this is going to be down here on the second image, and we're going to be able to identify the battery junction box as number 4. So number 4 right here, you can see in this area, this is where your battery junction block is going to happen. This is where we're going to be tying in all of the high voltage cabling from all the different cell stacks and all the major components that need high voltage power fed to them. To take a closer look at the junction block itself, it is a smaller unit that's bolted inside the battery pack, and it is a very important unit here. As it states below the junction block, it does include the system main relay, it includes the pre-charge relay, and it also does some communication with the vehicle control module to determine if there's any problems with any of the circuits. So our high voltage junction block is a very, very important part of the EV system, and it's great to give your students some exposure to these new and unique components that are special to EV cars. Now we're back working on our Nissan Leaf. We're going to look at some low voltage circuit protection and doing some troubleshooting here to determine if our fuses are good. It's important that you talk to your students about all the different fuse locations. I know I've already mentioned that before, but it's really, really important. When we test low voltage fuses, it's just like we do on any other car. If the circuit is live, we can take our negative lead and put it on our negative battery cable, bring our positive lead over, and we're just going to look for available voltage on either side of our fuse. And if the fuse is in good shape, we should see the same amount of source voltage on either side of the fuse. And it looks like these three fuses here are all in great shape. Now you do want to keep in mind though that there are other areas where fuses are located. There's another small fuse panel inside the car. On the battery cable itself, on the positive battery cable, are all 5 or 6 of your high current fuses. So these would be like 50, 60, 70, 80, 90, and 100 amp fuses. Not to be confused with the high voltage fuses for the lithium ion battery pack, but these are going to be your heavy current fuses. They're going to feed any electric motors or anything like that that's operating inside the vehicle itself. And then also over here on this side, we have the IPDM module as well. And if you flip the IPDM module over, you will also find that there are a series of fuses and relays underneath of this module as well. So most internal combustion engine cars don't hide the fuse boxes and the circuit protection, much like these EV cars do. They're kind of scattered throughout the entire vehicle. So I think it's good practice to send your students out and let them do some fuse testing on the vehicle itself. Since the high voltage fuse protection is located inside the battery pack of this vehicle, we're not going to be able to disassemble that for today's presentation, but we can look at a few more diagrams in the repair manual. So let's take a look at that now. Referring back to the repair manual, because we cannot drop the battery out of this car, we're on about step 15 of the battery disassembly. Now keep in mind there was a whole section on how to pull the battery out of the car, but we're about step 15 or 16 of disassembling the battery pack. And what we're seeing right here pictured is the top where you would put your service plug in. It would plug in right here, and then the case of the battery would be all around the exterior. So you've had to remove the entire case, split the shell open. There's a bunch of bus bars and wiring harnesses you have to remove. Then there's these 4 bolts that you have to remove. And then you flip this entire cover over. We'll see the picture here on the next screen. And when we flip this entire side over, what we're going to see here is the wiring connection for the PTC heater for the battery pack, as well as the output wire for the high voltage. And right here in the center, this is going to be our high voltage fuse for the Nissan Leaf. So trying to do the best we can to give everyone an example of where this fuse is located. It is not an easy process to get down to it, and you're really going to want to make sure that you've eliminated all other possibilities for what's causing your customer concern prior to going into this route. I've brought everyone back underneath the hood to kind of show you what type of relays you can actually put your hands on. Things like system main relay number 1, system main relay number 2, and the pre-charge relay. Those are all integrated into the battery pack, which on this particular vehicle is part of the underbelly of the car. But there are other control relays that we can get access to. Directly underneath the hood, we have our motor control relay. So if we pull the lid off this cover, we can see this relay is right here. And this relay can be tested. Obviously, we can use the scan tool like I just showed you, but you can also use a traditional automotive relay tester to test the coil side, to test the contact side, to make sure the relay is performing as it's supposed to. Other relays that you can find, there are also fail-safe relays, fail-safe charge relays. Those are also found in additional relay boxes underneath the hood. To continue our conversation about DC to DC conversion, I've brought everyone back out underneath the hood of our Nissan Leaf. Since I mentioned before, DC to DC conversion is primarily happening to charge the 12-volt battery. But the computer, the VCM, needs a lot of information about the state of this battery. So if we look at the negative side of the battery cable, we're going to find a 4-pin connector that connects to a sensor that's right on the negative side of the battery. This sensor is a temperature sensor and a current sensor. And it's going to send these 2 data inputs directly to the VCM, and the VCM is going to analyze all the systems that are operating in the car and the state of health of this battery, and then it's going to make a command to the power delivery module, the PDM, which is the main powertrain unit for the vehicle. It's going to make that command to see whether or not we need to increase the amount of DC to DC conversion, which will increase the amount of output, or whether we need to decrease that if our battery is charged up enough, because we certainly don't want to overcharge our battery. The DC to AC inverter can be found inside the power delivery module, or sometimes we like to refer to it as just the electric powertrain unit. This is the big unit that we see underneath the hood of this particular vehicle here. And there's a lot of the critical systems are included, all stacked together inside of this unit. At the bottom and kind of off to the side is going to be your traction motor with your gear reduction. We're also going to have our DC to DC conversion going on in there, as well as that DC to AC inversion, as well as all of the actual control features necessary to control that power delivered to the traction motor itself. Unfortunately, due to the high voltage situation that's underneath of all this, it's going to be almost impossible for us to do any actual testing or diagnosis outside of things like voltage leakage, or actually doing some winding testings on the on the traction motor coils as well. So in order to get a better look at what's going on here and a better understanding, I do recommend that you encourage your students to get their scan tool out and look at the data points that are available. Thank you for watching today. We really hope everyone enjoyed our clip. We really have infinite amount of possibilities with any of our vehicle technology trainer units that we have, whether you choose the Nissan Leaf or the Prius Prime. Both of them allow you to train your students on brakes, steering and suspension. If you're doing the Prius Prime, you can do engine work. Both of them have a full electric vehicle side, so you can talk about lithium-ion battery packs. We can talk about traction motors. We can talk about system main relays. So there's really a lot of possibilities for you and your students to learn on. So if you really enjoyed our content today, please be sure to check out our video library on YouTube. Also see our other social media pages on Facebook and LinkedIn, and we'll see you next time.